In this video, we're going to talk about the methods for the resident student class. We're defining the resident student class by using the inheritance relationship to inherit the data and methods from the student class and save ourselves time in the implementation of this new data type. We've already looked at how to define the data fields for resident student. We included two new fields, dorm and room number, and we're inheriting all of the other data fields from the student data type. Now we're turning your attention to the methods, and the important thing to know when you're using inheritance is that you only need to define the methods that were not part of the superclass. So when we're thinking about resident student, we're looking at what methods were not part of the student class, but are things that we want to include as methods for the resident student class. So let's first look at all of the methods that were part of the student data type. Here's a list of them. Think about which ones don't need to change. I'm going to highlight all of the ones that don't need to change in orange. Give you a second to look at them, pause the video, and then join back when you're done thinking about it. So let's think about the constructors. The constructors for the student data type initialize first name, last name, GPA, and credits. There's more information in the student or in the resident student data type, so maybe we're going to need to change those. What about setting the student's first name? Is there anything we'd need to do different if I was a resident student that I wouldn't do if I was a student? You can look back at your implementation to get more information about that. In our original student type, we said we wanted to set the first name by taking a new value for the first name and assigning that to first name. That seems like that's exactly what we would do if it was a resident student. There's nothing about their name that changes, so we wouldn't need to change anything about that particular method. For the same reason, we wouldn't need to change anything about setting their last name. Being a resident student also doesn't change your GPA or how you earn credits, so none of those methods would need to change. So I'm going to highlight all of those as orange because those don't need to change. What about getting the student's last name? Again, there's nothing about getting a student's last name that's dependent on where they live. And so getting their last name, getting their first name, retrieving the GPA value, retrieving the credits earned, none of those are going to change if we're dealing with a resident student rather than a standard student. The two-string method and the equals method, maybe those will change, kind of depends. If we were okay with only printing out the data that was specific to students, the first name, last name, GPA, and credits, then we wouldn't need to change anything about two-string. If for the resident student, we want to be able to display their dorm and their room number, then maybe we do want to implement a new version of that. And then the equals method. If we're okay with the definition that we have for standard students, then we don't need to change that for resident students. Let's look at how we implemented it for the standard student data type. So we implemented the equals method so that if the first name and last name of the students were equal, then we said that it was the same student. We didn't consider their GPA or their credits earned at all. And so again, if we were okay with that, then we wouldn't necessarily need to implement something new for the equals method. We could use the standard one that we had already written for the student class. If instead we wanted to change it so that we compared their first name, their last name, information about their room number, and so on, then we would want to change the implementation for the equals method. And as a developer, that's kind of your call. It's based on how you would use your new resident student data type in your project. So we've identified the fact that we maybe need to make a new constructor and that we might need to make a new two-string method. Everything else about the original basic student data type is going to be just fine for our resident student. Now, our resident student data type has additional data associated with it that wasn't part of this basic student data type. So we're probably also going to need some additional data or additional methods associated with it. Specifically, we might need a new constructor. We talked about that already. We might also want to be able to retrieve the value of the dorm or the room number and be able to set those two data fields as well. So those are methods that we're going to include in our implementation for the resident student data type because they weren't part of the original student class. So I'm going to switch over to IntelliJ so that we can write those methods. We're going to put them in the resident student data, resident student class, and we're going to write the resident student constructor first. Now, you probably remember that there's two different kinds of constructors, a default constructor and a non-default constructor. It turns out if it's a default constructor, there's probably nothing really interesting to do here because the dorm and the room number are both strings. Maybe it doesn't make sense to have a default value for those. So maybe in the default case, we're okay with it just calling the default constructor in the student class. But suppose we want to implement a version of the constructor that allows us to pass in information to initialize all 6 data fields that are part of the resident student. So we're going to want to type in or pass in the student's first name, the student's last name, the student's GPA, and this, sorry, that was a double. And the credits earned, and also their dorm, and finally the room. Super. So we're writing the non-default version of the constructor, one that passes in those 6 data values. Now, we could write all of the statements to initialize those data fields inside this method, and that would be cool. But we can also leverage some of the method that we've already written in the basic student class, because we already have this default constructor in the student data type that initializes the first name, last name, GPA, and credits earned. So we can actually call that from inside our resident student class. And the special syntax for calling the superclasses constructor is just the reserved word super. That means call the student types constructor because that's the class that we're inheriting from. When you call the superclasses constructor, if you're calling the non-default constructor, then you want to pass in your argument values. And our student types non-default constructor expects a first name, a last name, a GPA, and credits earned. So we're going to pass our arguments in that same order: first name, last name, GPA, and credits earned. And by doing that, it's going to call the default non-default constructor of the student type. It'll initialize those 4 data fields. And we've already tested that code and know that it works well. So we can leverage that in our implementation. Now in our implementation, we do need to initialize the other values, the dorm and the room number. So I'm going to set the data field dorm equal to dorm name. That's my parameter that matches up with it. And I'm going to set the room number equal to room. That's my parameter that matches up with it. And so if somebody calls this resident student type non-default constructor and passes in the 6 fields, the 6 arguments, it's going to initialize all 6 fields of the resident student data type. Let's also add in our getter methods and setter methods. We want to be able to retrieve the value of the dorm. Get dorm. We want to return the value dorm. And similarly, we want to be able to have one that's get room number. So those are my 2 getter methods. And I also want to have my 2 setter methods that take a dorm value as an argument and allow me to change the dorm, like if somebody moved mid-year or something like that. We want to set dorm equal to or I call them the same thing here. Let's do this.dorm. That's my data field version. I want to set that equal to my parameter version dorm. And then finally, I want to set the room number. And I named my parameter differently than my data field this time, so I don't need the reserved word this syntax. I can just say room number equals room. So I've implemented most of those methods that we identified. I did my 2 setter methods, the 2 getter methods, and a new default constructor for the resident student data type. We also talked about potentially wanting to implement a new version of toString. You can do that in here. So a reminder of what the basic class's toString method looks like. I added that down here. I'm going to copy and paste it and then change it. So the basic student class printed out the word student and then the first name, last name, GPA, and credits earned. We don't want to print that out because we're going to be making something specialized for the resident student data types. We want to print that as the data type. And then we would want to print their first name, last name, GPA, credits earned, and also the information about their dorm, and finally their room number. Super. Now in here it's telling me that I can't access the value of first name because it's private to the student class. Anytime you have data that is defined to be private in a class, you can't access it from outside the class, even if you're inheriting from the original class. So instead of saying first name here, can't access it directly, but we can call the get method. So I'm going to call get first name to retrieve the value of the first name. That's going to give me the same behavior. And of course, I'll be able to call the methods because those are public as a visibility level. Super. So I got rid of all my squigglies. It looks like my toString method is good. Let me refer back to the notes, see if there's anything that I missed. I think we got all of the methods in there. We talked about using the super class. And the notes I also talked about, like, suppose you wanted to override the equals method so that you compared room numbers or dorm names in addition to the student names. You could certainly do that. I'm not going to do that in my version that I implemented here in our notes. So I think we're all good. Let's compile just to make sure everything's cool, and then we'll write our main program to test out our new methods that we wrote for the resident student. Looks like everything's good, so we're all ready to write our main program code to test out our new class.